Welcome to Reductio, Adventures and Ideas. I'm your host, Andrew Lavin. Reductio is a show about philosophy, about ideas, and about understanding ourselves and our world more clearly. Brought to you by Inverted Spectrum Media. What the heck is a reductio? Let's take this first episode to explore the meaning of the name Reductio. Besides being a cool name for a podcast, what does the word mean? Reductio is short for the Latin phrase reductio ad absurdum, or reduction to the absurd. The Latin's actually closer to something like tracing back to the absurdity, but reduction makes for a more natural English translation. To fully understand what a reductio is, it might be easiest to start with an example.
It's funny, isn't it, how liberals contradict themselves all the time? Liberals say they champion women, but at the same time they celebrate abortion, which has killed 30 million unborn women since 1973. Contradiction. Liberals claim they respect a woman's right to choose, but then Hillary Clinton degrades all the women who chose to vote for Donald Trump. Contradiction. Funny how liberals tell us they are the party of the working man, but then every single Democrat in the House and the Senate voted no on a tax bill that cuts taxes for 70% of single moms. Contradiction. Funny how liberals tell us the tax cuts that we got in our paychecks, the $1,000 bonuses our employers gave us because of the Trump tax reform, liberals tell us those are crumbs. But then liberals claim $10 a month to pay for your own birth control, that is oppressive to women. Contradiction.
So this is loaded with falsities and perhaps deliberate misunderstandings, but it is an example of an attempt at a reductio. Liz Wheeler here is taking what she thinks is a position which stands or falls together, what she might call the liberal worldview. She's then identifying the internal incoherence of the worldview by pointing out what she perceives to be contradictory beliefs in the set of beliefs that make up the worldview. If the argument had worked, she would have successfully shown that the liberal worldview traces back to contradictory beliefs, and so is at least in need of revision, if not altogether rejection. She would have demonstrated that belief in the liberal worldview is absurd because the worldview is self-contradictory. I have my doubts that she was successful, and not for any other reason than that the argument pretty clearly rests on some false assumptions. Let's not walk too far down that rabbit hole, though. A reductio is one of the most beloved and well-used tools on the philosopher's tool belt. If you can take someone else's position, or general principle, or set of beliefs that they hold, and show that by accepting it they must also accept an absurdity, or perhaps that in accepting it they will have already accepted an absurdity, ipso facto, then you will have refuted them. You will have shown that their belief is absurd. Let's spend today getting to know philosophy a little bit by exploring one of the favorite tools of philosophy. We'll look at a few reductios and pick apart how they're supposed to work. So say you believe the Earth is a flat disk. Apparently this belief is having a little bit of a resurgence of late. If I can show that the implications of this belief are either inconsistent in themselves, meaning they contradict one another, or that the implications of this belief contradict something that everyone seemingly has to believe, then I will have thereby refuted the original belief. I will have shown that it is false because it leads to an absurdity. One reason for rejecting the flat Earth hypothesis is that it's just not as elegant as the theory that the Earth is a sphere. Another reason is that it can't explain as many of the phenomena that we come across in our explanation of the world around us. But what if we could show that the hypothesis that the Earth is flat was absurd? That would be a much stronger reason for rejecting it.
So my name is Joe Johnson, and I am a physics teacher at Newport High School in Bellevue, Washington. And I have been teaching for, this will be my third year coming up. And my background is in both geology and astronomy.
I talked with my friend from college about this. He has followed the flat Earth movement for a bit, and he was kind enough to dig into the hypothesis a little bit more. He found some interesting stuff.
I got my bachelor's in geology from Chico State. And while I was getting my bachelor's, and even for the few years after, I spend a lot of time studying astronomy, publishing papers on binary stars and on exoplanets for the most part.
Okay, so what exactly do these flat Earth people believe? If I was buying into the flat Earth hypothesis, what would I be accepting?
So the flat Earth hypothesis is the idea that the Earth is flat. Their usual image that they would portray of the Earth is basically that of the symbol of the United Nations. They believe that the United Nations picked that as their symbol because that is actually what the Earth looks like.
So if you don't quite recall the UN flag, it's a stylized wreath that's wrapped around an image of the continents of the Earth, as if you're looking down at the Earth from above the North Pole. There are latitude and longitude lines drawn around it, but most striking is that there's no Antarctica. So the Earth is supposed to look, according to the flat earthers, like the image on the UN flag.
It is a disk with the North Pole being at the center, and then the continents starting with North America and Asia and Europe radiating outward from the center toward Africa, South America, Australia. And then there is a wall of ice that surrounds the ocean around the perimeter of this disk. And then the South Pole, as we would know it, and in globular hypothesis, that would be kind of a circle, actually, that would go around the Earth at some distance away from the North Pole.
Wait, so why is there a cold, icy North Pole and a cold, icy ring around the outside? I guess I'd expect it to be one or the other, depending on where the sun is.
So the reason that the North Pole would be icy and the Antarctic ring or barrier around the Earth would both be icy is that they are the most distant points away from the tropics. So you've still got this ring around the middle of the Earth where the tropics would be, and that is where the sun and the moon would basically circle over the disk. So you'd still have colder areas the farther away you get from the sun.
So that's the flat Earth hypothesis.
That's what the theory is.
Okay, so the sun is rotating in a circle above the tropics, and as a result, the innermost circle of the flat Earth disk is far away from the sun, and so is the outer edge of the disk. So is it absurd? Does it have contradictory implications? Or maybe it has implications that are inconsistent with things we feel we must believe or cannot reject. If I want to believe that the Earth is flat, is there something I must believe that would be absurd? Let's explore some of the implications and see if we can find a contradiction. So, Joe, what are some of the implications of the belief that the Earth is flat?
You would certainly have to believe in geocentrism, that the Earth is the center of the entire universe. I mean, the sun itself, according to, it really depends on which version of flat Earth hypothesis you believe in. You would have to accept that the sun is incredibly small, maybe several tens of miles across. It is not a large celestial object of any kind.
An eclipse happens when an extra sky-colored X-moon passes in front of the sun.
And then similarly with the stars and the planets. In fact, you'd have to believe that the stars actually orbit or revolve around this flat Earth in a period of one day. A lot of them actually believe that there isn't so much a region of stars around the Earth, but rather those are fixed points that are on some sort of a dome that covers the disk of the Earth.
Some force other than gravity must be responsible for the fact that objects fall towards the Earth.
So, you'd have to kind of get rid of the whole concept that there is no up and down in space. There actually is an objective up and down in flat Earthism.
Some say that the disk Earth is accelerating upwards, which simulates gravity. In fact, Joe and his students recently calculated how far the Earth must have moved if it's constantly accelerating upwards, and it turns out to be further than the known diameter of the universe.
Other things are that you'd have to kind of give up any kind of belief that we have explored any of space. There is no International Space Station. There are no rockets.
Astronauts proclaiming the sphericity of the Earth are mistaken or are part of the grand globalist conspiracy.
And that kind of gets into something that you also have to, or oftentimes will start to accept, is other conspiracy theories, whether they are linked directly to the flat earth or not. It kind of creates sort of a mindset of conspiracy thinking. So you kind of have to give up on a lot of what others would say are rational beliefs.
And why must the disk Earth be fixed? Why can't it be rotating?
Well, if the disk is rotating, then you would expect to, this is the way that they view it, you would expect that you would actually feel that motion. You would feel like you were on a merry-go-round going around, but that's not what it feels like being here on Earth. You would feel like you were constantly being pushed to the south.
Okay, I guess that makes sense, but why not think that the International Space Station and satellites are just moving around in a circle above the disk Earth?
Well, the dome that covers the disk of the Earth actually extends above the sun and the moon, and so what you would expect is that those rockets and objects, when they look down toward the Earth, you would actually see the sun and the moon above the disk of the Earth.
Okay, so the Earth and its atmosphere actually forms a sort of hemisphere. So to get beyond the sky into outer space, you'd need to fly above the sun. That could get dangerous. Ask Icarus. But what happens under the disk? What if you dig straight down? I suppose if you dig down far enough, you'll reach the underside of the world? There's no telling what's going on there.
There are a lot of different ideas. There are some that would just say there is nothing there. It's just flat. But another thing that extremely often goes along with the flat Earth hypothesis is a strong religious conviction. There are a number of passages in the Bible that do kind of describe a rather flat Earth. You know, the heavens are stretched out like a canvas above us, and there are other passages about the dome of the sky and the firmament above the firmament. How can there be an above if the Earth is a globe? So there's going to be a lot of religion, and in that case, usually that would be where the location of hell would be underneath the disk.
And the sun is just projecting a sort of spotlight on the surface of the Earth. Doesn't it project in all directions? Presumably the sun is a sphere, maybe a very small sphere.
See, with light, light follows an inverse squared law, which means that the further away you get from the light source, the amount of light that you actually receive is significantly less. But they believe that, I don't even know if they have a specific mathematical model for the sun itself, but it basically violates the inverse squared law. The brightness of the sun drops off faster than what you would expect.
Oh, okay. So they have some sort of different mathematical model that says, like, for instance, that the light of the sun obeys an inverse cube law instead of an inverse square law, and so the light dims much more quickly than we standardly think it does. So, Joe, this is what you take to be the most coherent flat Earth hypothesis.
So what I'm trying to do is give you the most coherent and complete and the greatest explanatory version of the flat Earth hypothesis.
Well, a lot of those beliefs are pretty silly. And by silly, we might mean that they're inconsistent with lots of things that we already believe and don't seem to be able to do without. Are they self-contradictory, though? Maybe they're totally internally coherent, and the only problem is that they don't match up that well with the evidence. In fact, so far it's not clear that I've listed any contradictory beliefs. It seems like we may have a worldview that's at least consistent with itself. Put another way, take all the beliefs that make up the flat Earth hypothesis and all the implications of those beliefs, put them in a bucket, and see if they get along. If none of them contradict one another, then on some thinner definitions of coherence, you have an internally coherent theory. In fact, most of the contradictions that people identify in the flat Earth hypothesis are contradictions between other well-established facts and the tenets of the flat Earth hypothesis. So this hypothesis is absurd because it isn't consistent with the rest of what we believe, and not because it is by itself incoherent. It's absurd because you already believe a lot of other things, and all those other beliefs contradict the flat Earth hypothesis.
Well, one of the biggest issues that I would have is that we have certain technologies today that they would have a very difficult time, I think, explaining. Like, how do cell phones work, for example? They do not actually, your cell phone doesn't directly talk to satellites, it talks to the cell towers. And that's actually why we call them cell phones, is that it's a cell around a certain tower that communicates with the cell phones. But those communicate with the satellites in order to triangulate your position and those things. So I think that they would have a very difficult time explaining that.
For another set of examples, you probably believe that there are satellites which make GPS work and which collect climate data and enable global communication, for instance.
Yeah, so like GPS satellites are probably an even better example where they actually have to take into account time dilation in order to pinpoint your location on Earth. That'd be very hard to explain.
And that the moon landing actually happened, and not because of some grand coincidence between sphere-based mathematical calculations and the actual world where the Earth is a disk, etc., etc. You have an absurdity living in your mind if you try to house both the flat Earth hypothesis and a belief in satellite climate data or the moon landing. The flat Earth hypothesis then reduces or traces to an absurdity. Then there are some inconsistencies with everyday experience as well.
Yeah. Another thing that I remember is I was driving from Toronto one day and across one of the Great Lakes. I remember looking back toward the city, and I could only see the very tops of the buildings across the lake because of that curvature of the Earth. And actually, the lake appears to kind of be above the bottom of the city, whereas what you would expect if the Earth was flat is that I would actually still be able to see the other coastline and the entirety of those buildings across the lake. I'm not really sure how they would explain that.
There is also a host of apparent internal inconsistencies as well.
With the flat Earth hypothesis, in order to explain a lunar eclipse, what you need to have is the sun underneath the Earth projecting a shadow onto the moon. But I thought that the sun was supposed to always be on top of the disk of the Earth. So you end up with this total inconsistency.
The sun can't be both under the disk of the Earth and above it. There may be a contradiction here. So why would anyone accept the flat Earth hypothesis in the first place?
Another piece of evidence they would point to, and this goes really down to the conspiracy nature of it, of the hypothesis, is airlines actually commercial airlines almost never pass over or even near Antarctica. Rather, they skirt along the edge. There are a few paths that would take you within eyesight of the ice wall itself, but to my knowledge, there are actually no airlines that go over the continent itself and don't go over the South Pole. So that would be kind of another thing of why not? If the Earth is spherical, wouldn't there be some paths for commercial airplanes that would be fastest if you went directly over Antarctica? And just to kind of respond to that briefly here, if you actually look at the Earth from the South Pole, you notice that the most southern tip of Australia, Africa, and South America, none of them are 180 degrees apart. They're always a little bit less. So really, the straightest path would never actually go across Antarctica. But, there are some paths that potentially could, but they're just not very popular trips. So no airlines actually offer them at this point. So that would be kind of another conspiracy side of things of, why don't they actually send airplanes in that direction?
So if you were flying from, say, Sydney to Patagonia in Argentina.
And I believe you can from that particular flight. That's one of the ones that comes the closest. But the flight doesn't actually go over Antarctica, and that would not be the shortest path. That would actually take longer. Another reason why airlines wouldn't go over Antarctica is the Southern Sea actually has the strongest winds of any place on Earth. And so these airlines want to take advantage of that to conserve on fuel. So it'd be advantageous for them, even if it was the fastest path to go over Antarctica, to actually go around it so that they could take advantage of these extremely strong winds.
So I suppose you've bought into the conspiracy. Saving fuel, huh? I'm not buying it.
Right. Exactly.
I see. But aren't there reasons we encounter in our everyday experience that suggest that the Earth might be flat?
In terms of observations, I would say it's just kind of our lived experience, is we experience the Earth in our daily lives as being flat. And I think that goes to one of the points that I'd really like to make about the flat Earth hypothesis, is we could actually take it at face value as a scientific hypothesis. Let's try to describe the geometric shape of the Earth as viewed from an objective observer. And one objective observer would be someone standing on the surface and seeing it as being flat. Very much like how we experience in our daily lives a geocentric universe. We see the sun rise, we see the sun set, and we even call them that. We don't call it the Earth turn.
That does make sense when you think about it. We actually live most of our lives as if the Earth were flat. All right, I might be a flat earther now. What have you done to me, Joe?
So we could actually take this as a hypothesis and see what is its usefulness as a description of reality. And we can find that there are things that it has a useful description for. Things like getting from my house to the grocery store. A flat Earth is a much more useful model than bothering with what is the curvature that my car has to travel in order to get from my house to, and, trying to calculate all that out. It's not useful to me. I would much rather just have a flat map or on my phone, right, that just shows me that direct path, even if it's technically not true. But I would say that that's very much similar to trying to land astronauts on the moon. You don't need a much more explanatory version of gravity than Kepler and Newton in order to do that. You don't need to have Einstein's theory of general relativity in order to accomplish that goal. So why bother with it? So it does have some minimal explanatory power as a hypothesis.
Okay. I can buy it for everyday calculations like how to drive from Chico, California to Boulder, Colorado. For longer trips, though, we've found that it's far more efficient to assume that the Earth is a globe. And that's why when you're flying to California, say from New York, you fly over Washington and Oregon rather than Kansas and Nevada. In the northern hemisphere, the routes that airplanes take look like they arc to the north a considerable amount. So much so that we end up flying over Greenland on the way to Italy. Wait a second, though. What about the sunrise? How do they explain that?
Sometimes you do see lensing effects in the atmosphere, and it just depends on atmospheric density. And that's what actually a mirage is it's the lensing of sunlight or other light sources through the atmosphere. And they can actually make the light bend in such a way that it looks like there's a part of the sky in the ground, and that's what kind of looks like water off in the distance, and you're walking across the desert or something, right? That's a mirage. And that can happen for the sun as well. However, what it does with that lensing effect is it actually flips the image upside down, which is very strange. So when you look at the sun at sunset, sometimes you get this strange effect where it looks like there's sort of a piece of the sun sticking up as like a half circle above the sun itself. And that's actually the bottom of the sun being inverted toward the top of the sun due to this lensing effect. But you would never get the entire image of the sun itself projected below the horizon. It actually inverts the opposite direction.
So in fact, what happens, if we can accept the globular hypothesis as a fact, is the opposite of what happens in a mirage, where light coming from the sky lenses away from the Earth and hits our eyes. What in fact happens at the sunset is that light from really below the horizon lenses over the horizon and hits our eyes. We're actually seeing around the Earth a little bit.
Another effect that they'll often talk about at sunset is it looks as though the sun itself will approach the horizon and get smaller and smaller and smaller, just like you would expect if the sun were in the flat Earth hypothesis receding into the distance. You would expect it to appear to get smaller and smaller. The problem, if I may respond to it right now, is that when you see their videos and their images of this happening, the thing that they are calling the sun is not actually the disk of the sun. That is actually the glare of the sun, which is significantly larger than the disk itself. So if they were to try to do this experiment again with, say, a solar filter, so you're only seeing the disk of the sun in the sky, then you would actually not see that effect of the sun getting smaller as it approaches the horizon. The real reason that you see that is that the sun actually dims, and so that glare is less and less and less. So in the camera, it appears to get smaller and smaller.
So Joe, I'm curious, where did all this flat Earth resurgence come from?
I would just say that the flat Earth hypothesis also, I think, has a lot to do with YouTube culture, where clickbait gets you more and more views, and there are some people who have definitely taken advantage of that, and so they're putting out a lot of false information intentionally and knowingly, just so that they can get more clicks on their videos. Not necessarily the flat Earth believers themselves, but news organizations, science channels on YouTube, they will have a video that says flat Earth debunked, or talking to a flat Earth theorist, and then they'll have some sort of a catchy thumbnail. And I think that that's helped to kind of really propel this whole flat Earth movement into our modern conversations. I think it has a lot to do with sort of the Tide Pod movement as well. You may remember a few months back, maybe it was a year ago or so, that there was this whole thing about how kids were eating Tide Pods. And I looked into the actual CDC background on Tide Pod eating, and actually there were only maybe a few dozen cases of children actually consuming, and teenagers consuming Tide Pods before it became this internet sensation and phenomenon, when all these news organizations and other media outlets were reporting on the phenomenon. And then actually the number of real instances spiked. It went up into the thousands of cases of people getting severely sick and injured by eating Tide Pods. So I think that sometimes even having these kinds of conversations can propel them to being more widely heard and even possibly accepted by those who are open to conspiracy theories.
Thank you, Jolyon Johnson, for spending the time to walk through the wacky world of the Flat Earth movement. Your students are lucky to have you.
My name is Joe Johnson. I approve of this message.
There we go.
Let's switch gears and talk about another fun reductio ad absurdum, an argument that takes a claim or a belief, draws out its implications, and then shows that those implications are absurd. The next reductio I want to take a look at is a bit tongue-in-cheek. Here's Jessica Gonzalez, and I'll let her tell you who she is.
All right, my name is Jessica Gonzalez. I am a graduate student at UC Irvine in the Logic and Philosophy of Science program. Before that, I was teaching for the University of Hawaii system, mostly at Hawaii Community College in UH Hilo, and I taught there for about 8 years.
So what, pray tell, is Pastafarianism?
Pastafarianism is the religion that comes from, well, it's also called the Church of the Flying Spaghetti Monster.
That's right, folks, the flying spaghetti monster who hath crafted the natural world with its divine noodly appendages. That's what we're here to talk about. Anyways, how did this all come about?
Okay, so the timeline of the Church of the Flying Spaghetti Monster begins, I would say, about 2004, 2005. So in the beginning of the year, in 2005, the Kansas Board of Education is having some hearings to determine whether intelligent design should be given equal time, equal to evolution in science classrooms. And so a physics student from Oregon State University, Bobby Henderson, decides to send in his thoughts to the Board of Education, and he doesn't hear anything back from them.
So Bobby Henderson gets interested in this legal battle involving the Kansas Board of Education. They want to figure out whether they should allow or even mandate that a theory like intelligent design should be taught in science classrooms. Henderson sends this letter in and gets nothing in response. So far off to an inauspicious start. The letter is worse than poorly received. It's not clearly received at all. So do we ever get to see this letter?
And so a few months later, it seems that he decides to publish this open letter on his website. So when he publishes this open letter on his website that he had given to the Kansas Board of Education, its popularity is just incredible. And basically what he is doing is he is telling the Kansas Board of Education, look, you're saying that you want to teach intelligent design in science classrooms just as much as you teach evolution because it's a scientific theory. And so intelligent design really is different than what we've seen with creationism historically. So creationism, this idea that God created the world, the book of Genesis, that, in modern times is kind of hard to keep up with, given all the scientific evidence that we have that things aren't exactly how it seems to be from that story. And so intelligent design is a little bit rawer, if that's a word, than creationism, because what it does is it kind of strips away all of the religious aspects and really gets down to what we might call an argument from design, or a teleological argument.
So if we can't all be young Earth creationists, then perhaps we can teach something that isn't so clearly flying in the face of scientific evidence, like young Earth creationism appears to be. So we'll teach this thing that's been instead stripped down to a position according to which there's an intellect at work in the creation of the universe, and then perhaps at work in the creation of life. Intelligent design is that stripped down theistic account of evolution that's supposed to be a rival account of the origins of living things than the account we get in modern Darwinian biological theory. Since it's a scientific hypothesis, just like Darwinian evolution by natural selection, it must, they argue in Kansas, be given equal time in public school classrooms. Jessica wanted to make sure that we note that some people at least appear committed to Pastafarianism. Of course, we're not here to mock anyone's belief system. Instead, the goal is to understand how this movement came about as a response to a movement to teach intelligent design in the public school system. If you know a real-life Pastafarian, or if you are one yourself, I'd absolutely love to meet them. Please have them contact me. Anyways, back to the story.
From the outside looking in, you can see that what they're trying to say is, look, intelligent design is still not science, where you might strip away all of the religious aspects of it, but once you do that, it doesn't get you science just because you're stripping away the biblical aspects of it. It's still not science. If you're going to argue that it is science, then you have to admit that the flying spaghetti monster fits the criteria of an intelligent designer just as much as any other sort of god might as well. So if you're going to say that we can teach in our public schools that intelligent design is a tenable opponent against evolution, then you have to admit that the flying spaghetti monster could be an example of such an intelligent designer.
In some ways, this is the most intuitive form of reductio ad absurdum. You take someone else's argument or position, show that it has absurd consequences, and then use that fact as a basis to reject their argument or position. In this case, the consequences are truly absurd. A monster that is either made of or closely resembles spaghetti and meatballs is the thing that's responsible for the creation of the universe. It reminds me of South Park, where the God figure ends up being like this deformed hamster-looking thing. Why not? God could turn out to be Alanis Morissette for all we know. So, Jessica, how exactly does this work as a reductio?
Okay, so there's this argument for teaching intelligent design in classrooms, and it goes something like, scientific theories should be taught in science classrooms. Intelligent design is a scientific theory, therefore intelligent design should be taught in science classrooms. Well, if we take that conclusion, if we just suppose that intelligent design should be taught in science classrooms, well, Pastafarianism is an intelligent design theory. Therefore, Pastafarianism should be taught in science classrooms. Now, we clearly don't want Pastafarianism to be taught in science classrooms, so we get some sort of contradiction going on there, which causes us to reject that prior conclusion that intelligent design should be taught in science classrooms.
So you think we should teach intelligent design in science classrooms? Pastafarianism is a version of intelligent design, so you think we should teach something that could end up being Pastafarianism. If the flying spaghetti monster is one possible intelligent designer, in other words, then intelligent design as a whole looks kind of silly. Or maybe, dare I say, absurd? So what else do Pastafarians believe? This is a pretty funny set of beliefs.
So here's some fun facts about Pastafarianism. Pirates are divine beings, and they were given a bad name by the Christian theologians of the Middle Ages and Hare Krishnas. In fact, pirates were peace-loving explorers and spreaders of goodwill who distributed candy to small children. Ghost pirates are responsible for the mysteries of the Bermuda Triangle. Holiest of Pastafarian holidays is September 19th, which is International Talk Like a Pirate Day. They didn't invent that holiday, but it's their holiest of holidays, the High Holy Day. So in his letter, he says that there's a correlation between the average global temperature and the decline of pirates. So basically, global warming is caused by the decline of pirates. Right? And as his evidence, he shows a graph where you have the increase of the average global temperature and the decrease of the number of pirates. In about 2005, he estimated the number of pirates in the world to be 17, starting off at 35,000 a few hundred years ago. So it was a great way to teach, that correlation doesn't imply causation, and that's how I started using it in class.
Remember, folks, just because two things are correlated, meaning when one goes up, the other goes up, and when one goes down, the other goes down, it doesn't mean that there's any causal relationship between them at all. It might just be an accidental correlation. I suspect that the relationship between pirates and global temperatures is not a causal one. So this is clearly meant in good fun to some extent. It's supposed to be a way of saying, look, the claims you're making are a little ridiculous. Let me show you just how ridiculous they are by revealing perhaps the most absurd consequences of your view. That's in essence what a reductio is. I'm actually not so sure that the logic of the flying spaghetti monster works. Quickly, here's what I'm thinking. Just because creationists want intelligent design to be taught in the classroom doesn't mean that they automatically have to teach a particular version of intelligent design. The hypothesis that is being taught in classrooms could simply be that there's an intelligence behind the creation of life, no details needed. So even though you could easily come up with 1,000 absurd versions of intelligent design, it doesn't follow that intelligent design is itself absurd. We just need one workable version of it to show that it's not absurd. Reductios can be used in advanced logic and mathematics, in conversations between friends at the pub, and in theological disputes. Our everyday reasoning is full of reductio proofs. Think of when you say something like, but if you believe that, you also have to accept this, and that's Crazy Town Banana Pants.
Talk to me about Crazy Town Banana Pants.
That's John Hodgman in the gas leak season of NBC's Community. Anyways, this is part of the reason philosophers love reductio so much. They're so useful. At the end of our journey, we've seen that there are two types of reductio ad absurdum, external and internal. An internal reductio is more like the flying spaghetti monster argument. If you believe that, then you have to believe something absurd, so your original belief is absurd. An external reductio is more like a rejection of the flat earth hypothesis. If you believe that the earth is flat, then you have to reject a lot of things that we believe about the world. So what if the earth were flat, but was created by a flying spaghetti monster with their noodly appendages? Then we'd be in a very absurd world indeed. Thank you to Jolyon Johnson and Jessica Gonzalez for their expertise in these weird subjects. Anyways, now you know what a Reductio is. See you next time on Reductio, Adventures and Ideas. Next time we'll be continuing on with the cosmological theme. We'll talk with Michael Fitzpatrick of Stanford University about one of the first proofs for the existence of a god or a creator in Western history. Guess what? It's a Reductio proof. Thank you for joining us. If you're enjoying the show, there's no better way to show your appreciation than by reviewing us on iTunes and Google Play. Subscribe to the podcast using your favorite podcast app too. You can also support us on Patreon at patreon.com/Reductio. You know, a lot of people have heard of the Greek philosopher Aristotle, but very few have heard of his treatise on Greek history, which claimed that
In fact, pirates were peace-loving explorers and spreaders of goodwill who distributed candy to small children.
Reductio, Adventures and Ideas is a production of Inverted Spectrum Media. Until next time, I'm Andrew Lavin.